This is section 3-4, intercepts of graphs. So I can identify intercepts of functions and solve equations by graphing. These are standards AREI 10 and FIF 4. So this is also very conceptual. We're going to use Desmos a lot. So this is very similar to all the sections that we've done so far. We need to know what the x-intercept is, the x-coordinate of a point where it crosses the x-axis. The y-intercept is the y-coordinate of a point where it crosses the y-axis. A root is a solution of an equation, and a 0 is an x-intercept of a function. So we got a lot of stuff going on. You probably need to write this vocabulary down, highlight it, make sure we know it. Okay, so the x-intercept. Here in the orange, we have our x-intercepts. So it looks like I have an x-intercept. Well, they're all in between, so we would have to estimate. But the orange is where the graph crosses the x-intercept. It can cross the x-intercept multiple times and still be a function. The y-intercept is where it crosses the y-axis. It's the green over here. And it's only going to cross the y-axis once if it is a function. So, a function is positive where its graph lies above the x-axis. So here we have everything up here in the light blue. This is all where the graph is positive. The opposite is true for negative. So negative is all down here. Where the graph is below the x-intercept. That's all negative. Ignore that. Part. So identify the x-intercept here. So the x-intercept is x equals 3, because this is at 3. And the y-intercept is at y equals 6. So we have to talk about now where it's positive and negative. So it is positive anywhere above this 0 on this x-intercept. So we would write that by saying it's where x is less than 3. The reason we know it's less than 3 is because it's from here on, and that is less than 3. Here's 3, and it's everything that direction. The graph is negative here when it's below the x-axis. So this is 3 once again, but it's going to be on the greater than side of x, so it's going to be x is greater than 3. The graph shows the height of a ball for each second x that is airborne. Use the graph to estimate the x and the y-intercept of the functions, so where the function is positive, and interpret the meaning in context of the situation. So this is like a basketball being shot or a ball being thrown. So we're going to say we start at 4 feet because that's about where your arm is. This right here, it asks us to identify our y-intercept, so y equals 4. Then we have to identify our x-intercept. Well, the only place we cross x is x equals 9. The function is positive all of these spots. So it's positive in between, and we define it by x value. So it's positive in between 0 and 9. So I would write something So it's positive between 0 and 9. So it's in 0 is less than or equal to x is less than or equal to 9. So that means it's in between there. This graph is not negative here. It never goes down here, so it is not negative. And what happens in this situation? So you throw a ball and it goes up. So the ball goes up, reaches its max height at like 9 feet, and then over time it falls to the ground, and at 9 seconds it hits the ground. That's what's happening in this graph. So this is important. 2. See where it crosses x equals 2? So this is the solution of this function. It is also the root of this function. It is also the 0 of this function. And it is also the x-intercept of this function. So all these words are interchangeable. That's important to know. So when you get asked for the root, the 0, the solution, or the x-intercept, that is where it crosses the x-axis. That's what we're looking for. This is important. Make sure you star it so you know. So solve by graphing. So what I've done is I've put this on Desmos, so we're going to check it out. And let's go back. We're looking for a solution, so we are looking for the x-intercept. So we're looking for the x-intercept, and that's going to be our solution. So let me get Desmos up here. So all I did up here was I actually just put it in the way it is. So I have negative 2x plus 7 equals 1. And then all I have to do is see where it crosses the x-axis. And it crosses the x-axis at 3. That is going to be my solution. So my solution is x equals 3. Seems pretty simple, right? So now here I did the exact same thing. So all I need to do is go back to Desmos. I need to highlight this one instead of this one. And then if I look, it looks like I have 2 solutions here for this one. So I have an x squared term, so I would expect to have 2 solutions because I have 2 x's. So one of my solutions is x equals 1. The other one is x equals 3. So I just put x equals 1, x equals 3. And here's my last one of these that we're going to look at. So I am just going to highlight this, not highlight this. And then I highlighted the purple there. So I just put it in as it is. And I don't see anything on the graph. If I zoom out, so you always want to zoom out and check, but I don't see anything. And what that means then, there is no solution. So we should be able to prove this. So we're just going to write no solution, but we're just going to go ahead and combine the like terms and see what happens. So I'm going to put the x's on one side. So minus 4x minus 4x. Well, that crosses out and that crosses out. Well, that's a problem, really, because that leaves me with 3 equals negative 5. Is that true? No, that is not true. So that's why it's no solution. So Haley is ordering invitations for a graduation party. She has $40 to spend, and each invitation costs 96 cents. The function m equals 40 minus 0.96p represents the amount of money m Haley has left after ordering p party invitations. Find the 0 of the function and describe what this value means in context of the situation. So I have m equals 40 minus 0.96p. So I did not put this one in there because I want you to see me put it in. So this is going to be, we're going to change m to y. and P to X. So we're going to put this in Desmos just this way. So 40 minus 0.96X. So we'll get rid of that. So I'll do 40 minus 0.96X. And then I'll put equals Y. So we're going to have to zoom out on this one and see what that means. So this means the solution is 41.96. So what that means is that's how many party invitations she can buy. That's how many party invitations she can buy for her $40. So 41.667. So really, how many is that? We'll have to round that, right? Because you can't do that. So 41 party invitations. So hopefully you learned a little bit about how Desmos can help you solve equations. Once again, like I said, this is mostly conceptual. So we have to be very careful with vocabulary, and we have to have a true understanding of what we're talking about and how it applies to the graph.